Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at simultaneous equations as part of the A-level mathematics syllabus. So here's an example. 2x plus 5y equals 9. 4x plus 3y equals 11. They're two different equations. They have to be satisfied simultaneously, that is at the same time. So we've got to find values of x and y that work in both equations. So we're going to start with a slightly easier one. Let's say 3x equals 6 and 3x plus y equals 10. Well, in this case, if 3x equals 6, it's easy to work out from the top one that x equals 2 because we're going to divide both sides by 3. If we know that x equals 2, that means we can put it into the second equation, which will tell us that 3 times 2 plus y equals 10. So 6 plus y equals 10, so y equals 4. So x is 2 and y is 4. That one was pretty easy. Go back to this one. It's a bit more tricky because in neither of the equations can we get x or y on their own. So what we're going to do is we're going to multiply the top equation by 2, multiply the left and the right by 2. So instead of 2x plus 5y equals 9, it's going to be 4x plus 10y equals 18. Then what we're going to do is take the equations away from each other. So basically what happens is we take the bottom equation from the top equation. So we know that 4x plus 3y equals 11. So we take 4x plus 3y away from 4x plus 10y, which leaves us with 7y. We take 11 from 18. So the point is, we're taking the same away from the left and the right, because 4x plus 3y equals 11, so they're the same thing. And then we take 4x plus 3y away from the left-hand side above, and then 11 from the right-hand side, and that's a valid operation. So we get another equation. 7y equals 7. Divide by 7, y equals 1. So y equals 1, and then what we're going to do is substitute back in. So if 2x plus 5y equals 9, y equals 1, that means 2x plus 5 equals 9. That means 2x equals 4. That means x equals 2. So what we got was y equals 1, x equals 2. That's pretty cool. Let's check back. Just check back into the equations. So if x is 2 and y is 1, that means the top one will go to 2 times 2 plus 5 times 1 is 9. 4 plus 5 is 9. And then the next one, 4 times 2 plus 3 times 1 is 11. 8 plus 3 is 11. There's also another way. Instead of subtraction, we can do it by substitution. So we've got 2x plus 5y equals 9. These are the same equations. 4x plus 3y equals 11. What we're going to do is get the x at the top. We're going to write it on the left in terms of y. So what we're going to do is, if we take 5y from both sides and divide by 2, we get x equals 9 minus 5y over 2. Then what we're going to do is substitute that into the second equation. So we're going to get 4 times 9 minus 5y over 2, which gives us 2 times 9 minus 5y. We're going to add on 3y, that gives us 11. Then let's expand out that bracket on the left. 2 times 9 minus 5y is 18 minus 10y plus 3y. So we get, if you take 18 from both sides and then you do minus 10y plus 3y, what you get is minus 7y equals minus 7, so y equals 1. If y equals 1, then you've got 2x plus 5y equals 9, which means 2x plus 5 equals 9, which means 2x equals 4, which means x equals 2. Same answer as we got before. And yeah, y equals 1, x equals 2, same as before. But there's one more nuance. So, well, there's a few more nuances, but there is one nuance we're going to look at right now, which is 2x plus 5y equals 9, 4x plus 3y equals 11. But what if it were like this? On the last example, we could do it by just doubling the top equation, and we get the same number of x's. But here it's a bit more complicated. We can't just multiply one of the equations by a number to get the same number of x's or y's. So what we've got to do actually, well, one thing we can do is multiply the top one by 3 and the bottom one by 2, and then in each case we'll get 6 x's. So multiply the top one by 3, left and right, and you get 6x plus 15y equals 57. Then you multiply the bottom one by 2 on the left and the right, and you get 6x plus 8y equals 36. Now you can take the bottom one away from the top one, so you get, take them away, 7y equals 21, because 57 minus 36 is 21. 7y equals 21, y equals 3. y equals 3, and then we go back to one of the original equations, any one of the original equations, we put in y as 3, so we get 2x plus 5y equals 19, which means 2x plus 15 equals 19, which means 2x equals 4, which means x equals 2. Same sort of method. And then finally, one last thing to say is there is a geometric interpretation of simultaneous equations, which is we can draw all the points x, y that satisfy the equation 2x plus 5y equals 19. We can draw all the xy points that satisfy 3x plus 4y equals 18. I've drawn them here. Isn't it beautiful? And they touch at one point, and the point they touch is where x equals 2 and y equals 3, which was exactly our solution. So instead of doing it algebraically, we can just do it as geometrically as a picture, and then we can see that the solution is where the two lines meet. I hope you liked this video. I liked making it. You're very welcome to subscribe and hit the notification bell. I'd love to hear your ideas, and I hope you enjoy your mathematics. That's the most important thing.